Okay everybody, in this chapter we'll be reviewing configuring storage and file systems. Our objectives: describe what server storage is, how to configure local hard drives, working with virtual disks, and describing file sharing. We'll then go on to configuring Windows file sharing and then how to secure access to those files using permissions. With the amount of data that we are currently saving to our systems growing exponentially, the need for faster, bigger, and more reliable storage is growing as fast as the technology can keep up. In this video, we will talk about some of the basics of server storage. Specifically, what is it? 2, why you need it. And 3, common methods for accessing storage. So, what is storage? Well, generally, storage is considered any medium that can be written to and retrieved from. Some long-term storage includes USB memory sticks, secure digital SD cards and compact flash cards, CDs and DVDs, magnetic tape, solid-state drives, and hard drives. When looking at storage, there are generally 4 criteria that we look at. First, the speed. How fast can we access or write information to storage? How much space does the storage provide with respect to its cost? And finally, longevity. How long will these drives last? Server storage is primarily based on hard disk drives, or HDDs, although solid-state drives are gaining popularity. Other storage mediums such as magnetic tape, CD, DVDs, flash drives, flash drives and SDs just really don't have the amount of space that we really need. Another type of drive which is gaining popularity is the solid-state drive, which, unlike hard drives, has no moving parts. SSDs use flash memory and the same type of high-speed interface as we would typically find in a traditional hard drive. Usually this uses either SATA or SATA-E interfaces, and again has no moving parts, which provides additional advantage that it uses less power and is faster and more resistant to shock. Some of the reasons why we need storage would start off with a place to save the hard drive or a place to save the operating system. The OS itself requires a good bit of storage. However, typically with respect to operating system files, we want this on a drive by itself, and it should be a relatively fast drive. Another piece that needs a fast drive are page files. Page files are used as virtual memory and to store dump data after a system crash. During the ongoing operation of a server, the server is constantly moving information in and out of real memory and uses the page file as a virtual form of memory. Therefore, it's very important that the page file be located on a drive that provides very fast, high-speed access. Other things that we need to keep track of or to store would be log files. Now, for the most part, these are relatively small in comparison to so many other things. But again, they can grow dynamically depending on how the system is used. Many times, if I find that a system is having problems, I end up finding log files grow much faster than one might expect. So typically, if I have my log files are starting to fill up my hard drive, I'm generally looking for a problem. Virtual machines. Virtual machines need considerable amount of space both for their operating systems as well as for their virtual hard disks. Another growing area for storage is database storage. Databases consume a tremendous amount of space and therefore require larger and larger hard drives. Finally, user documents. Things such as Word, Microsoft Excel, PowerPoint can use a considerable amount of space, but generally not as much as one might see, let's say, in a database storage. Database storage is probably the biggest consumer of storage that we have within our systems. When talking about storage, it's important to understand some of the different ways in which we access that storage. And there are three broad categories of storage access. Local storage, or direct attached storage, called DAS. Then there is network attached storage, or NAS. And finally, storage area network, or SAN. The first two, the first one is generally used in smaller servers, in which we have a hard drive within the server or a box closely connected to the server. We're going to go through the rest of these in greater detail, but again, the network attached storage, generally I use this type of storage for smaller types of organizations, small companies and so on. It's relatively inexpensive to attach this storage to an Ethernet network like we would attach any other kind of networking device, and it allows us to access this storage or these hard drives over TCP/IP. The third, the storage area network, this is what is used for larger storage solutions, and this is also probably the most expensive, and it does provide a far greater amount of storage as well as tremendous speed. So again, let's go back and dig in. Local storage is storage media with a direct and exclusive connection to the server's system board through a disk controller. Often you'll find this type of storage is actually inside the server itself, although sometimes it can be located just outside in another box which might have its own power supply but has a high-speed connection. Often this is a SCSI or a serial attached SCSI device. Usually refers to HDDs or SDDs instead of CDs or DVDs. We never anymore use CDs or DVDs for storing, not even for backups anymore. Typically, if you're going to be doing a backup, you're going to use maybe some form of tape, or you might use a less expensive hard drive. In either case, local storage does provide rapid and exclusive access to that server. The problem is if you have many servers, then each has to have its own drive, and then we have difficulty sharing this information between multiple servers, let's say in a cluster configuration. So the disadvantage is only the system where the hard drive is installed has direct access to this storage medium. Closely associated with local storage is your direct attached storage. And this is similar to local storage, but can also be referred to one or more hard drives in an enclosure with its own power supply. In the figure down below, you see a server with a DAS system. It almost looks like a server unto itself, but it's designed primarily to hold a number of hard drives with a very fast hard drive controller interface. A DAS device typically sits in its own enclosure, has its own power supply, and is usually configured as a disk array. Some of these devices have multiple interfaces so that more than one computer can access this storage medium simultaneously. Network attached storage, which I had mentioned before I generally use in smaller environments, is a device that is hooked into the Ethernet network, just like we would hook in our workstations or routers or switches, and allows both servers and user workstations to access multiple hard drives via the network. Sometimes your NAS is referred to as a storage appliance. NAS is typically dedicated to file sharing. Okay, we generally don't use this type of storage for, let's say, databases, and we would not store our operating system or our paging file on this type of device. NAS shares files through the standard network protocols such as SMB, NFS, and FTP. All of this running on top of, or this is all running on top of TCP/IP. All right. Now, the fastest and the most expensive of our storage solutions is the storage area network. The storage area network uses high-speed networking technologies to give servers fast access to very large amounts of shared stores. Now, when we talk about a network, we're not talking about an Ethernet network. This particular network is really designed for high speed and a couple of devices in relatively close proximity to one another. Most of the common networking technologies used in a SAN would be fiber channel or iSCSI. Now, iSCSI allows us to access a hard drive across a Ethernet or TCP/IP network, but often you can also use serial attached SCSI or SAS. The SANs use the concept of a logical unit number, and you'll often see this in SCSI type configurations. And the LUN is a logical reference point to a unit of storage that could refer to an entire array of disks, a single disk, or even just a part of a disk. Here we have essentially two networks. On the right, circled in red, is the SAN network, and you'll notice in the middle of the SAN network there is a dedicated SAN switch. Now, this is very different than your typical Ethernet switch. This is designed specifically for accessing storage devices containing multiple hard drives. You'll also have your various servers that are attached to this SAN network. On the other side of the file servers is the typical network that we're used to working with, and not only provides intercommunications between some of the file servers, but also provides communication with the various clients that are attached to our network. When it comes to configuring our local disks, we generally break them into two categories: the actual physical disk and logical disks. So a physical disk involves disk capacity, physical speed, as well as the interface for attaching the disk to the system. The logical disk properties, however, include its format, the partitions, and the volumes that are created on the physical disk itself. Some of the terms which you should be familiar with when talking about disk storage. First would be the disk drive, which is the physical component or the drive itself. Again, this could be a SCSI drive, it could be a serial attached SCSI or SAS, it could be iSCSI. In less expensive servers, it could be a SATA drive or SATA Express. Next, you've got the volume, and this is actually a logical unit of storage that can be formatted with a file system. Now the volume many times can consist or be comprised of multiple drives or sit on a single drive, and a single physical disk drive can also contain more than one volume. An older term that we used to use was partition, and this is the term similar to a volume. After partition, we've got formatting, and depending upon what your objectives are, we have different ways of formatting our hard drives, and this is really going to depend on the type of file system that you're going to be using to help to organize and store files. Some of the criteria are going to be what kind of operating system and what are you going to be using this for. We have a number of different formats that we can use, and we'll get into those in just a little bit. Disk capacity and speed. Whenever you're looking at disk space, storage space for your servers, one of the very first things that you're going to be looking at is how much space do I get and how fast can I access the information that is held on these drives. When it comes to hard drives, capacities are now measured in thousands of gigabits or gigabytes. So a 4 terabyte drive, essentially a terabyte being 1,000 gigabytes, are very common today. Factors that affect the speed of our hard drives include our disk interface. Okay, is it SCSI? Is it SAS? Is it SATA? These are the different types of disk interface technologies that we generally see. The next thing is rotation speed. How fast does the drive spin? The faster the drive spins helps us to access the information more quickly. So I can access data faster on a 15,000 RPM drive than I can, let's say, on a 10,000 or even less 7,200 RPM drive. Another thing that helps us with the overall speed of your storage system is the amount of cache memory that is installed. Sometimes this memory will be located actually on the drive itself, or it may be located on the controller for the drives. Disk capacity. The Windows installation should be on a separate disk from the data itself. An SSD is a good choice for Windows installation, although I kind of question that a little bit because of the number of writes. SSDs tend to be more expensive. They have great transfer rates in terms of the speed to access the data. However, again, I really very concerned about their longevity. However, when it comes to the Windows installation, most times what's occurring is the system is reading from the Windows installation. It's not writing a lot of information. The thing that gets written to quite a bit is the page file. And again, here we'd want to put the page file, which again is kind of virtual memory, if you will. We want to put the page file on an SSD or a separate drive from everything else. This should be the fastest drive in your system. And it used to be, even in the mainframes, we used to have these specialized drives. They were called swapping drives, and they were used for virtual memory, and they were smaller in terms of their capacity, but they were very high speed in terms of the time it would take for us to access the data. The time was very short. In either case, I'm a little leery about using SSDs for this particular application because of the number of times that that information is going to be written to. Another thing that we want to consider when setting up our drives is fault tolerance, and to do that we want to use some form of RAID. Okay, RAID allows us to combine multiple disks to make a single volume and essentially create a much larger space in which to store our data on. Overall storage capacity is diminished when you use RAID. However, typically if you set up a RAID multiple drives, you are going to lose a certain percentage of those drives depending upon the number of drives that you're using in the RAID. But just be aware that if you've got, let's say, 4 1 terabyte drives, your total capacity is going to be 4 terabytes. However, your overall drive space when you are done configuring RAID is going to be less than the 4 terabytes. So just something to be aware of. There's a price for that fault tolerance option. We talked about the disk interface technologies that are used in interfacing with our hard drives. And in a workstation, many times the hard disk controller is built right into the motherboard. However, in servers, it is not unusual to see a separate hard disk controller as some sort of add-on card. These controllers provide very, very fast data transfers and thereby allow the system to both read as well as write to the disks very quickly. Again, some of our options here when it comes to disk interfaces: SATA, SAS, and SCSI. And just keep in mind that SAS is a newer version of SCSI. Okay, so SATA is probably what we typically see in our workstations. SATA was used to replace the older drives, what we refer to as the IDE drives, and it was a parallel ATA drive. Okay, it used a parallel bus for moving data. And while parallel transmissions may seem like the way to go because you're essentially sending data through multiple channels of communication, i.e. parallel. However, what we've found is that serial is able to run more quickly and is also less expensive. And that's where SATA comes in today. SATA means serial, and the data is sent serially rather than in parallel. So it's inexpensive, it's fast, and it's very reliable. Some of our current standards for SATA would be 3.2, and it can support speeds up to 16 gigabits per second. Most readily available devices support either SATA 2 or SATA 3. But again, SATA is not an interface that one would normally use in a server. I might use that in a small company type server, but anything for a medium to enterprise level server, I would generally use a SCSI or SAS. So again, as I just said, in a larger system I'm going to be using a SCSI interface. Now SCSI is the older technology. It too has a parallel bus and still used. In fact, I'll have to pull out one of the servers that we've got and show you what SCSI looks like. Today, however, we use a variant of SCSI, only it's serial, okay, and it's called SAS. It's newer. It's the serial form of SCSI with data transfer rates up to 6 gigabits and higher. SATA drives can be connected to SAS backplanes as well. And a backplane is essentially, think of it this way: if you've ever installed any kind of add-on card and you plugged it into the bus of your workstation. Well, in essence, that bus is a backplane. And so what happens is we're able to plug these drives and drive controllers into this backplane, which provides an extremely high speed interface and is used instead of traditional cables. Volumes and disk types. So we said before, a volume can use some or all of the space on a hard drive, or a single volume can actually span multiple hard drives. When talking about Microsoft servers, there are generally two Microsoft specific volumes that need to be defined within the system. First is the boot volume. The boot volume is where Windows folder is located, also called the boot partition. Next is the system file, and this contains the file the computer needs to find and load the Windows OS, also called the system partition. This is created automatically during our installation when you're installing the OS for the first time. It is also not assigned a drive letter like what you might see with the boot volume. So here is our disk management screen, and what we're seeing here is we're seeing that we have several drives that are attached, or these may be physical drives. Okay, this is one physical drive, and then we've got a drive C that has been configured with the filing system of NTFS, and we can see that it consists of 126 gigabytes, and there is the system volume and 450. I'm not sure if that's system or which one there is system. One of these is probably for utilities by the server manufacturer. In either case, you have drive C here, okay, and that's the 126 gigabits. Well, if we look down here, here's a breakdown of drive C, or physical disk 0. And you'll notice that we've got the 450 right there. We've got the 99, okay? So this 450 is actually a recovery partition. So it has, probably files for restoring the system in the event of we lose drive C or something. Then you've got drive C at 126 gigabits, okay? And it shows that, number one, it's healthy and that it contains the boot, the page file, crash dump, as well as the primary partition. So all of this is showing one physical drive inside this computer system that is then broken into multiple volumes. And these volumes are being used for different things. The most important volume here is the largest one, drive C. Now, there are different types of disks when we're working inside Windows. We start off with basic disks, okay, and these accommodate only what are called basic volumes, or called simple volumes. They can't hold volumes spanning multiple disks, okay? So if you're trying to set up a RAID configuration, you can't use a basic or simple volume, all right? Volumes are a basic disk and are called partitions, all right? They can support a maximum of up to 4 partitions. So the first 3 are primary partitions and the 4th is called an extended. This is all pretty old stuff, but we still have it around and we still can configure this stuff. We can still have the primary partitions and the extended partition, but for the most part we get away from this. You're generally not going to set a server up with simple volumes. When it comes to partitioning, okay, Windows offers 2 methods. First is called the MBR, or Master Boot Record, which is the most common method and has been around for forever. It supports volumes up to 2 terabytes. Then you have the GUID partitioning table, or GPT. This supports volume sizes up to 18 exabytes. Okay, so an exabyte is 1,000,000 terabytes. And this became the option for Windows Server 2008 and Vista. Starting with Server 2016, new disks are initialized with GPT, but you can still select MBR if you wish. Also, GPT offers improved reliability through the partition table replication, or CRC, protection of the partition table, which is extremely important. So here's a look at some drive information through PowerShell. Moving on, we mentioned already simple volumes, which reside on a single disk, whether it be basic or dynamic. Then when it comes to dynamic disks, we can have a span volume, and this is a volume that extends across 2 or more physical disks. Next is a striped volume, which is like a span volume, extending across 2 or more dynamic disks, but the data is written to all the disks in the volume equally, which allows us to perform that task much more quickly. We also have a mirrored volume, which is a RAID 1 volume and uses space for 2 dynamic disks and provides fault tolerance. So essentially what happens is you have 2 drives, okay, and they are mirror images of one another, such that if one drive fails, we have the second. So whenever you do this, you might have 2 terabyte drives, and as a result, when you combine them in a mirror volume, what you end up with in terms of capacity is simply 1 terabyte. Okay. The other RAID that's very common is RAID 5, and what this does is uses the space from 3 or more dynamic disks and uses a disk striping with parity, such that if a single disk were to fail, I'm able to literally figure out what the missing data is, and when the drive gets replaced, I can dynamically recreate the information from the lost drive. We had talked about disk formats earlier, and again we have various options for the different types of formats that we can place, or we can format our disks once they have been configured. So formatting creates the directory structure needed to organize the files and store the information about each file, as well as the data. So the file system defines the method and the format an OS uses to store, locate, and retrieve files from any kind of electronic storage medium. Some of the formats that we have available to us would be FAT, which is an older file system, and we saw in our very first PCs, NTFS, which has now been around for I think we got NTFS in '94 and has really been around for quite some time. Then we've got Resilient File System, and this is the one that is used for very large data stores. Okay, today most of our systems still use NTFS. However, if you have a very large data store where speed is paramount, you're going to consider the Resilient File System. So with any file system format, okay, some of the things that we're looking for is file naming conventions, what they allow us to do, how are the files and folders organized hierarchically, data storage method, the ability to store metadata, attributes about the files, and access control lists, which are the foundation for our file system security. File systems also vary in whether and how each component is used. So, to start with, FAT, or the file allocation table, consists of two variants, FAT16 and FAT32. These file systems were used as far back as DOS days, okay? And with FAT16, we're limited to 2 gigabyte partitions. FAT32 allowed us to get to 2 terabytes, but Windows 2000 and later limited the size of FAT32 partitions to create just 32 gigabyte for performance purposes. FAT32 also supports files up to 4 gigabytes in size. That's barely enough to hold a full-size DVD. Some of the limitations of FAT. The file size limitation to begin with prevented us from storing a DVD image on a FAT system. They don't support file and folder permissions for users and groups. They lack the support for encryption, file compression, disk quotas, and reliability features. And FAT is simple and has very little overhead. However, it was prone to errors. Okay. Still, the file system of choice on removable media, such as flash drives, is a form of FAT. NTFS and resilient file system. NTFS was introduced in Windows NT, and it supports both file and folder permissions, a big advantage over FAT. Features that were added with the release of Windows 2000 would be disk quotas, volume mount points, shadow copies, file compression, and EFS, or the encryption. Resilient file system, the main use is for large file sharing applications such as databases, where the volumes are managed by a technique called storage spaces. RFS does not support file compression, disk quotas, or EFS because all of these simply slow down access. Windows also cannot boot from an RFS volume. RFS supports volumes up to 1 yottabyte, okay? And RFS works with storage spaces to automatically repair disk failures caused by corruption. The disk format of choice for storing virtual hard disks for the use in storage spaces as well as for Hyper-V servers is RFS. It is not meant to be a replacement for NTFS. Okay, so let's move on and talk about the process of preparing a new disk, specifically within a server, not so much within a necessarily a DAS device. But most servers, okay, most systems that are designed from the ground up as a server, not a workstation converted into a server, but servers, provide for hot swappable drives, and these are, or as we refer to them here, as a hot add. A hot swappable drive is a drive that can be inserted, installed, or removed from a server from outside of the case. In a workstation, most of your drives are mounted inside the case, and in order to get the drive out, you literally have to open the case, probably even turn off the machine to get that drive out. In a server, however, the drives are mounted through an opening on the outside of the case. So when we say hot swappable, we're saying that the drive can be removed and replaced while the system is still running. And we did see that a little bit. We'll see if I can get a picture on the next slide for you to look at. Or better yet, we'll look at it in class because I've got a couple of servers that have hot swappable drives. In either case, this is very important because if we have a drive that goes bad, we don't necessarily want to take the server down. What we want to be able to do is we want to remove the bad drive, and then we want to slide a new drive into place. Once we go through an initialization process, that drive then becomes available to the file server or to the Windows operating system. So the Windows server supports hot adding or hot swappable drives, as long as they put it here, the hardware does as well. And as I said, most servers today do provide for this. The other thing that you need to be aware of is when we're talking about hard drives, often we're setting them up with some kind of RAID configuration. Typically you have the choice of configuring RAID. It's either through the operating system or you configure it through the hardware. There are literally routines within the hard drive controller that allows you to configure RAID. If you have the choice, not all servers will necessarily have this, but even midline servers to high-end servers are going to have this capability. That RAID capability is built right into the hardware. Okay, and you don't necessarily want the Windows operating system handling the configuration of RAID. Okay. Anyway, after the hard drive has been attached to the server, we would use the disk management snap-in. By default, your new disks, they need to be initialized, and then afterwards we can go about and we can create a volume on them and then format that volume as needed. In our disk management, we can also convert the disk from a basic disk to a dynamic, or between an MBR or GPT partitioning schemes. Managing your disks with PowerShell, here are a couple of commands down below that we use in PowerShell for essentially formatting, adding, configuring our hard drives, rather than, let's say, using the disk management snap-in. So to get a list of your disks, simply say get disk, bring disk 1 online, set disk 1, set disk, that is the command, dash number 1 or dash number is the parameter, and then 1 is the variable that we use, and is offline is false. Okay, so then we have initialize disk number 1. Next, create a partition on disk number 1, and then finally we would go and we would format. In this particular case, we're formatting it with the REF or RFS. So here's a picture of a typical file server, and what you're seeing here is this particular server has 10 removable drives. They generally have these handles that we use to release the drive and then pull them out, as well as lock them back into place. And when you do that, when you push that lever back in, it essentially pushes the edge connector into a socket such that we make all the electrical connections. And then there's this door down here that basically closes and protects all of this stuff. But these would be hot swappable drives. Okay. All right. Let's see. Moving on to virtual disks. Virtual disks are, the way we manage them is very much like the way we manage physical disks. A virtual disk, if you will, is simply a file which exists on a volume in a physical disk. And again, we can create virtual disks using our disk management. We can also use our PowerShell commands. Virtual disks also can be mounted by double-clicking in a file explorer or by right-clicking it and then clicking to mount. Your virtual disks are also portable because we can move them from one system to the next, which is one of the biggest advantages. It's very easy to move a virtual disk and a virtual machine, for that matter, from one system to another system, giving us the option to either, one, back it up, or two, move it to a different system and run it there while we may be doing maintenance on the original system it came from. When you work with virtual disks, you have the option of either selecting a VHD or a VHDX format, and essentially here are some of the a comparison between these two. We've been using primarily in class the VHD. It's a simpler format, doesn't have all the bells and whistles and the strengths of the VHDX. However, here are the differences. To begin with, VHD supports a virtual disk up to 2 terabytes, whereas a VHDX supports up to 64 terabytes. The X also uses a block size of 4K or 4096, whereas the VHD simply uses 512, considerably smaller. Okay, so if you're going to be moving lots of data, okay, the 4096 is the better way to go. With the X disks, you can store custom metadata such as what type of operating system, build number, who built this particular disk, and maybe even some descriptive information as to its purpose and so on. Also, the X drives are more resilient to power failures because it tracks updates in the metadata. So they stand up better to sudden power failures. Although that's something that we should really work to avoid whenever we are building our server infrastructure. Also, you can use you can convert your VHDs from to a VHDX drive using either the Hyper-V Manager or PowerShell. So here's the screen for managing within Hyper-V for your VHDs. And here is the option to go in and basically convert between a VHD and a VHDX. We've discussed this before, but one of the options that you will have when creating virtual drives is whether they are going to be a dynamic drive or a fixed size. So dynamic means dynamically expanding. So for example, let's say that you set up a 100 gig drive, and you've got these two options. If you select the dynamically expanding option, what this does is it creates an initial drive of, let's say 10 gigs. And that's 10 gigs that is stored on the physical hard drive. This initial 10 gig drive has the ability to grow to 100 gigs. However, it will not grow, okay, until you start putting data on it. Okay, as you put data on it, the physical size of this disk, and remember, VHDs, okay, virtual hard drives, are files that sit on a physical hard drive. Okay, so a dynamic VHD is not going to really increase in size until you start adding some data, but as you do, it will incrementally start growing to that maximum that we said of 100 gigs. You might create a drive with 200 gigs, okay, but you're gonna initially create it, you're gonna set it with a maximum limit, and then it's gonna start out, you know, relatively small. The other way that you can go is you can create a virtual disk that is a fixed size. So rather than you know, creating that dynamic 100 gig, we're going to create a fixed size 100 gig drive. When you do this, the file that gets created on the physical hard drive is 100 gigs. It's fixed. It's already allocated. Advantages. Dynamic drives allow you to start out with a small amount of disk space and grow as you need it. Fixed size disks are immediately take up the maximum amount of room that they are defined for. The advantage between a fixed size and a dynamic is that when the server needs disk space, if it needs to increase a dynamic drive's size, that takes time. Whereas with a fixed size VHD, the space has already been allocated, it's already there, we don't have to wait. So fixed are faster in some respects than dynamic. All right, but dynamic are more efficient from a space point of view. Okay, so there are definitely good reasons for both. If I were doing a database, okay, if I had a database and I was processing a lot of transactions and things like that, I would use a fixed size VHD. However, if I were storing, let's say, user documents, whether they be, you know, let's say Word or Excel or PowerPoint, I would use a dynamic drive, okay, because I'm not so much concerned about the speed there and I want to try to minimize the amount of space that I'm initially taking and just basically allocate that space as we go. All right, so that's something to think about when you're creating your VHDs. All right, so let's move on to file sharing. File sharing is the ability, as its name implies, of us being able to share files with other users. In addition to sharing files, we have the ability to also share printers. And quite honestly, it was file and print sharing which was the original reason why we implemented local area networks and file servers. When a local area network, when we first started creating these and rolling these out into the office or the department, they were primarily for the purpose of sharing files like Word and Excel and things like that. We really didn't have, you know, database systems yet, but the whole idea was to take advantage of a very large hard drive and store all of our stuff there. And quite frankly, one of the things that we used to do was a lot of our workstations didn't even have hard drives. We had a diskette drive that had just enough information on it to get it to boot the network interface card and get the workstation onto the network, and then from there access the server's hard drive. So a lot of our original workstations, when we started implementing local area networks, a lot of our workstations didn't have hard drives because they were expensive. And if we built, or if we got one large hard drive and then shared it with the rest of the department or company, then we were saving our money. It was not also unusual for a large hard drive back then was maybe 80 or 100 megs, okay, believe it or not. So in comparison to what we're dealing with today, very small. But back then, where many systems were still diskette based, this was a big jump. So even today, file and print sharing is still a very big function or role that our servers play. The way our Windows systems share these files back and forth between the server and the Windows clients is using something called SMB, or the server message block. This is simply a application layer for formatting the data as it goes across the network. We also SMB is as they say, a variant of the common internet file system, but there are also other formats that we use out there as well. Windows Server 2016 also supports NTFS, which is used primarily in Unix or Linux operating systems. So if you're going to be supporting any of those clients, or you want to interact with servers running Linux, then you want to install this this role into, or not this role, but it's actually more a feature or a protocol to support the exchange of files. Server for NTFS is a role found under the file and storage services, and you need to install it if you're going to support those types of clients. Creating Windows file shares, there are a couple of different ways that we can do this. Some of the methods that we can go about doing it, they say that you need to be an administrator, and that's not necessarily the case. You can create file shares provided you just have the right privileges to do so. In either case, some of the methods that we have to configure folder sharing: simple file sharing, advanced file sharing, dialog box, the shared folders snap-in, as well as the file and storage services. So here what we see is we're accessing a particular folder, and what we're doing is we're going in and we're identifying what permissions an administrator is going to have, whether they're having read capabilities or read write, and so on. We'll take a closer look at this in a lab. Here is the advanced sharing screen, and again, what happens is you identify a folder, you give that folder a sharing name, which can be different than the folder name, okay, but I recommend that you keep them the same. It just makes things a lot easier. And then you identify, how many users you're going to allow, put in some comments as to what's in this share. Okay, what types of files, who should be allowed to access this. And then you'll notice down below we've got permissions. So in this, we're going to identify who's going to be allowed to access this folder and what privileges will they have when they access the folder. Alright, so creating shares and set a number of share options with the new share wizard basically just steps you through the process. Some of the options that we have for setting a file share: we've got the SMB Share Quick, the Advanced, Applications, NTFS Quick, and NTFS Advanced. Again, walking through the wizard, you see that it just takes you step by step through this process as to how you want to share it and so on. All right. You can set the following additional options for your SMB share. Enable access based on enumeration. Shows only the files and the folders to which a user has at least read permission. Okay, and anytime you're setting up security, this is always a good idea. Only allow the user to see what they are allowed to access. Anything else should be hidden. Okay. The first technique in security is simply don't tell everybody what you have. Hide it. Okay. I used to have a client. They had this beautiful data center, and it was adjacent to the company lobby, and they've had these big glass windows that allowed you to look into the data center. And we went in and we basically said, you know, honestly, you should put shades on those windows. You should not let people be aware that you've got servers in that area. Okay, so if you want to protect something, the first thing you're going to do is hide it, and then there are other security techniques that we can use, but the first and easiest is to simply not tell people that it exists, where it is. Just hide it. And that's what enumeration does, is it essentially hides folders that users don't have access to. If they have at least read access, they can pull information out of that folder. But if they don't even have read, then there's no reason they should even be aware that a folder exists. Allow caching of shared file shares. This enables you to either turn it on or turn it off. And also known as client-side caching. And what this does is, especially for client workstations and so on, what it will do is it will move a copy of this share out to a client, and the client can then go offline, work on the data, and when they come back, that information on the client's laptop is then synchronized back to the file share on the server. You got to be careful with this, especially when you've got multiple people. If you've got multiple people accessing something like this, then this is not something I would be using. Encrypt data access. Retrieving files from the share is encrypted as it moves over the internet. This can be extremely helpful to have, depending upon who all is on your network. If you've got, let's say, visitors that may be accessing your network, you don't have a separate segregated network for visitors and so on, you might want to consider this. The other thing that we're going to do anytime we set up a share is identify the permissions. First, who's allowed to access this particular folder or the share, and what are they going to be allowed to do? Are they going to be able to simply read what's inside? Are they going to be able to change? Are they going to be able to delete files? Are they going to be able to create files? Okay, and we'll get into more of what are the specific permissions that are allowed. And here we see that. Okay, so for a given folder or share, we're identifying, okay, who's allowed to do what? Well, the person who created this share has full control. All right, users, okay, within the system, they get special, which means that it's defined further, and they also have read and execute, which means they're allowed to see what's in this folder, and they can also execute it if it's a program or application file. With respect to administrators, administrators by default generally get full control, okay, as well as the system gets full control. Okay, so when it goes to managing your shares, you're going to use your the snap-in to create, delete, and monitor your shares, view open files, monitor and manage user connections and sessions. This is nice because you can see who's accessing what shares, how many users are connected to a share, and so on. The shared folder snap-in does give you the ability to view all of your shares, their paths, how many clients are connected. Sessions, this lists the users who have a network connection to the server, and then open files specifically shows those files that the users are accessing within those shares. So the shared folder snap-in is great for just monitoring activity with specific shares. As always, we can create file shares using PowerShell commands, but we can also do it from a command line or the command prompt, and using what are called net share commands. And in this, the most basic is just net share, and this will show you, list the shares on a particular computer. Or you can do net share, the share name equals, and then the path of the folder. Finally, if you want to get information about a particular share, just net share and the name of the share, and you can also delete the share. So nothing really big there. So here are some of the command line, or I'm sorry, PowerShell commands that we've got, and I'll allow you to just review those in the book. Default and administrative shares. Whenever you set up a server, the installation process creates some shares automatically. One of the easiest ways to identify those shares is with a $ symbol. If you see a share name with a $ on it, that means that was a share that was created by the operating system when we initially installed and configured the operating system on the server. So you have admin, which basically points to the boot volume, the Windows folder, if you will. You'll see shares in there, C $, D $ for drive C and drive D, IPC, which is your inter-process communications. Then if you set up a domain controller, you'll also see that we've got net logon and sysvol, which is the Active Directory folder. When accessing file shares from client computers, there are a couple of different ways that we can go about doing this. You can either use UNC path, in which you basically will put in something like / server name / share name, or you can do an Active Directory search or mapping a drive. And you can do that either from the command line, or you can do that in Windows Explorer, or you can just by browsing the network and drilling down on a server to a folder to its contents. Going back to our NFS, which we said was used to support Linux and Unix computers. Again, this is a role or capability that can be installed into our servers if you have these machines that you are supporting or you're exchanging information. Again, as they say at the bottom here, you need to add that role if you want to have that capability. But don't add it if you don't have Linux workstations or servers and so on. Don't bother adding this. Installing and configuring essentially just takes you right through the share process. Implementing an NFS share is very similar in many respects. Just take the wizard, step yourself through it. It's really not a big deal. Here are some of the PowerShell commands. Again, very similar to some of the PowerShell commands we saw for setting up a typical Windows share as well. Securing access to files with permissions. So we have a number of different permissions that we can configure. That gives us a lot of flexibility in terms of what people are allowed to do within a given share. So two ways to secure files: either set up share permissions or file and folder permissions. And a permission specifies which users can access a file system object, such as an Excel spreadsheet. and what the users are allowed to do with that object. Am I allowed to open it? Am I allowed to read it? Am I allowed to modify that file, namely write it? Am I allowed to delete it? Okay, sometimes you don't want users deleting files. They're allowed to change it. They may wipe out all the content inside of it, but they can't actually delete the file itself. Share permissions apply when using network access to shared files. So if I'm a remote user and I connect to a server with a share, it is the share permissions which are going to determine what access users are going to have. And this is what we really want to focus on, because most people who access a server are accessing it through the network. They're not sitting in front of that server and accessing it through the GUI, if you will. Okay, they're accessing that server through a file share, okay, over the network. Next, you've got file and folder permissions. Always apply whether accessing network shares or just local files. Okay, security principles. These are people that are allowed to essentially access, the different components of the system, whether they be users or they be groups or computers and so on. An object's security settings have three components that make up its security descriptor: a discretionary access control list, who the object owner is, and who the system access control list. Okay, so discretionary access control list, or the DACL, is a list of security principles. Each has permissions that define access to a given object, whether that object is a computer, a folder within a computer, any kind of device, printers. All right. Your access control entry is an entry in the access control list. The object owner generally is the person who created it. The system access control list itself, or the SACL, defines the settings for auditing access to an object. How permissions are assigned when a user creates an object. Initially, the user's account is generally added to the DACL, and this method is called the explicit permission. So if you create a file, you're automatically given owner privileges, which is generally full control. A group that the user belongs to is added to the DACL. So I can give permission to a group of users rather than to a single user, which is often the better way to go. And we're going to be talking about later on how we set up our groups and users, and how we hand out privileges and permissions and so on. So permission is inherited from the DACL of a parent object the user or group has been added to. So often if you have specific access to a folder, then you would have a similar access levels to any subfolders or files underneath that. The effective permissions, this is what happens when we pull together your privileges based on you as an individual, or the user as an individual, and based on the privileges given to any groups that the user may belong to. So if a group, if a user belongs to, let's say, a backup group, they'd be able to go in and read files. So here we see the typical permissions tab for a file share, and you can see that we've got the users that are allowed to access this particular share, along with what permissions they have, whether it be full control, change, or read. And often, when we talk about full control, there are other options here. use the add button to add additional users or remove, and then you select the appropriate permissions. There are a number of additional permissions that we have. File and folder permissions can be configured on folders and files. Folders have 6 basic permissions, and there are also 14 advanced permissions, which essentially provide greater detail or a greater level of control with respect to the folders. Files, there are 5 basic and 13 advanced permissions. Some of these basic permissions include the ability to read or read and execute, or list the folder contents, write to a folder or to a file, modify that file, namely change it, and then full control, which gives you everything. File and folder ownership. Whenever anyone creates a folder, they are made by default the owner of that file. However, ownership can be changed, and it can be basically taken over by the administrator, or the administrator can assign it to someone. And we'll talk more about the strategy on how you go about assigning that kind of stuff. Inheritance, again, if you have a folder and then a subfolder, any permissions that you have in the parent folder, you will inherit those same permissions when accessing the subfolder. Okay. Again, here are some of the advanced settings. We talked about the basics. Well, here we're getting into the advanced settings for the different types of permissions. Effective rights, again, this is the total rights that you have based on who you are as an individual and what groups you belong to, because groups can be given, effectively given, their own set of permissions. When you add what you have as a group as well as your individual, that gives you your effective rights. And it's typically ANDed, okay, or ORed. If you have it as a user or you have it as a member of a group, you get it. You get that access. And again, this is what that looks like, basically looking at a given folder and telling you what it is that you're allowed to get access to and do. You can also use a deny, where you can explicitly go in and deny certain things to users so that they don't accidentally inherit something that you didn't intend to give them. Okay. Some of the rules that you should keep in mind when setting up your permissions for files and folders. First, a file or folder copied from within the same NTFS volume or to a different NTFS volume inherits permissions from the destination folder. Okay, so where you're copying it to. A folder or file moved within the same NTFS volume retains its original permissions. A file or folder moved to a different NTFS volume inherits the destination's folder's permissions. A file or folder moved from a FAT or FAT32 to an NTFS inherits again the destination's folder's permissions. And then finally, a file or folder moved or copied from NTFS to FAT, okay, you lose all permission settings because FAT doesn't track any of that. Okay, so permissions are out the door. In essence, you've got access to everything. Okay, so that's the chapter. As always, please write down any questions that you may have, send them to me, pull me aside, but let me know what you've got in terms of questions. Okay, thank you.